So at this point, you know just about everything in the world about graphing polynomials. Do you realize that? You've become incredibly powerful. You know your remainder theorem, factor theorem, and how to do that. You know multiplicities, you know roots. Well, let's go then. Example 5 should be a walk in the park for you. Look, there's x squared means guess what? You've got a multiplicity of 2. That's a multiplicity of 1, that multiplicity of 1, which means this is just going to cut through this guy like this, just cut through the x-axis like this. This is going to be a multiplicity of 2, so that has to be a bend in it. Okay, so let's state the zeros for this. Well, the zeros then are 0, and 0 because they appear twice. Normally, you would not say that. You would say, oh, what are the zeros? It's going to be 0, it's going to be 2, and minus 3. That's all you're going to say. But the important thing, the reason why I put down 0, 0 here is because I want you to be able to look at that and say, oh my gotcha, that means there's got to be a bend there. And what kind of bend is it going to be? Well, of course, it's going to be a bend like that. And guess where the bend's going to be? Right at the origin, because in fact, that is 0. So let's put this down. There's the 0, 1, 2, there's the thing that's going to cut through, and 1, 2, 3, there's the other cut. Now, notice the leading coefficient on this thing is positive, which means you have to have at least 2, 3, 4 roots. So guess what? There's 1, 2, 3, because it's a multiplicity of 2. 4 roots, you're good to go. Oh boy, oh boy, oh boy, look at all the fun we're going to have now. Okay, so let's rock and roll. Let's see what we can put on here. So I wonder what this guy's going to look like. Okay, being that it's positive, being that you have a multiplicity, or I should say a degree of 4, I have a prediction that they're both going to be going upwards, right? You're going to probably come down through here like this. You're going to bend around here, circulate here like this, right through. There's our multiplicity of 2, so there's your parabola shape, and then I think it's going to go up like that. That's my prediction. Okay, so let's go to the graphing calculator and let's do this. Got it in there already. I'm going to hit graph, and lo and behold, I was exactly right. Oh, look at that. Woo, baby, baby. Granted, my minimums here are a little bit off, but I was just sketching anyways. Now that you see what it looks like on your graphing calculator, sketch this a little bit more accurately. You may actually be asked to find what is the local minimum here and here. You might have to find that guy, and you might have to find that one as well. You never know. You could, but let's just go on. I don't think this asks for that. No, but it does ask, what are the window settings? Oh, there's something I haven't done. Let's take a look at the window settings that I used. Now, the nice thing is I actually graphed this before the podcast started. So I chose a nice window setting. Look at that, minus 10 plus 10, because I knew my zeros are going to be not that large. But look at this. I try to balance out my Y min with my Y max, so I don't get this really kind of skewed looking graph. Right? And I just played around with these values until I got something where they all fit in there real pretty like. Okay? So there's my window settings. And you can write your window settings down here like this. You can say that your X window setting was from minus 10 to positive 10 with a scale of 1. Okay? Your Y window settings were from minus 30 to positive 30 with a scale, again, I did of 1. Okay, all right, whoop-de-doo. Now, let's get back to the important stuff. So you had a multiplicity of 0, I should say a root, a 0, of 0, 2, and minus 3. Let's put it down. 0, 2, and minus 3. This had a multiplicity of 1, that had a multiplicity of 1, which means it just cuts through. Let's see if I spell it right this time. Oh, I did. Same thing with this one. This one just cut through. Okay, now what else do you have here? You have a multiplicity of the 0 multiplicity twice, so this is going to be a U-shaped. Okay, a parabolic shape there. Degree of the polynomial, add up the multiplicities. 2, 1, and 1, think about it, that's the degree of 4, which means also that the sum of the multiplicities is also 4. Using technology, find the minimums. Oh, duh, we got to figure it out anyways. Okay, so let's go back here. Let's graph this thing, and let's find this minimum. And there's only one real minimum that I'm interested in, and that's this one down here. Okay, let's find it. Second calc. Let's find that minimum value, which is 3. Left bound, here we go, all the way down here. I don't know why it's being funny. There it is. Enter, right bound, enter, guess. My minimum's at minus 2.15 and minus 16.3. So you can actually write down the minimums the way they want you to down there. Everybody's happy. Okay, now let's go back to this and say the y-intercept. Is there a y-intercept on this particular one? Well, yeah, we know what the y-intercept is. It's right here at 0. What gave it away? Oh, simple. The y-intercept that gave it away was right. Look, there's our multiplicity right there. And the fact that that has no movement one way or the other. Okay? So that had to be at the 0, 0 point. Okay, what else can we conclude about this? Is there anything else? Oh, the y-intercept is 0. Okay? Wow, is that ever cool that we can find all this information out just by knowing a few solid facts?